Yeah, thank you. It's a pleasure to be here. So I guess you know this here. In Austria, where I come from, we call this Krapfen. And I know you have different terms for this here in Germany. In most countries you call it Berliner, but in Berlin you call it Pfannkuchen, as I learned recently. And I don't know about you, but in Austria we consume Krapfen mainly during Carnival, during Fasching, as we call it. It's available around the year, but its main season is Carnival. And during Carnival, people try to be funny, haha. And so some people take here the ingredients, for instance, the jam that is in here, take it out and replace it by mustard. But just for one of those Krapfen. And if you have bad luck, you get this one with mustard, and this leads to a very bad taste experience. So please don't do it. I don't like it. Don't play with food. However, I think this little story shows that quite often a small change has a huge impact. And this might be also the case with architecture in the world of Angular. For instance, think about Redux and changing out Redux. More and more companies, more and more communities think about exchanging Redux by something that is a bit more lightweight, by a lightweight store. And so the big question is, what will change here? And I have the impression a lot of things will change if you go down this road. What do I mean when I'm talking about a lightweight store? Well, for me, a lightweight store in Angular is just a service providing some methods. I'm triggering those methods, and this makes the service doing some things. Those things can be synchronous or asynchronous. The store acts like the Duracell rabbit. It does something, and after that we get new data. And this data is put into some kind of reactive data structure, like an observable or a signal or something like this. And because of having this data structure, the data can flow down into the component, or to be more precise, into the component's template. So this is what I mean when I'm talking about lightweight stores. So the big question is now, why do we need stores in general? Well, obviously, we need a store to manage state. This should not come as a surprise. However, there is a second reason, at least a second reason, namely stores streamline your data flow, your reactive data flow. Stores are really beneficial for your data flow architecture. Because if we talk about a reactive system, we have the chance that one change leads to another change, and perhaps this change leads to a further change, and that change leads to the first change, and this is something you want to avoid. This leads to applications you cannot easily reason about, you cannot easily debug. It leads to, as I call it, an incredible machine. Perhaps you know this game. Who knows this game, The Incredible Machine? Yeah, some of you. It's a very old game from the 90s. It's a physics game. So I would say, as an architect, the main goal of this game is to produce a side effect. Look here. Here the bowling ball goes down, and then it is triggering the cannon, which is triggering the balloon, and so on. So it's really a lot of fun to do this game and to find out how to place everything and how to use physics to reach your goal. However, if your application looks like this, then you really have an issue. Then you have a piece of code that is not maintainable anymore. And this is the risk if you go with a reactive system. And funnily, with a store, regardless if it is a lightweight store or a Redux-based store, you can streamline this. You always have a command that goes upwards in the sense of a method, then something happens, and then the data flows down with a signal, with an observable, and that's it. Some people call this the unidirectional data flow. You just do a round once per event, per user interaction, or something like this. And another aspect why I like this slide is, this slide really shows where signals currently shine. They shine here on the right side. They are currently a good fit for bringing data into your template. This is the current main use case. I'm quite sure this use case will be extended over time, but currently this is where we are on the right side. So the thing is, lightweight stores are not an invention of the Angular community, not at all. A lot of other communities, as you see here, have already adopted lightweight store. They started questioning Redux by default already several years ago. And meanwhile, also in the Angular community, we have a quite nice lightweight signal-based store. It's the NGRX Signal Store, the newest member of the NGRX family. And today I will use this store to showcase how such a store changes some rules of your architecture. Because this is the main question I want to answer. And to answer this question, I have prepared several things. We will get started with what I'm calling a baseline architecture. And on top of this architecture, I will discuss several questions around how our architecture might change. Questions like, how large should the store be? Is it everything like in Redux, or is it a bit smaller? Where to put such a store? Also, what to do with global state and or local state? And last but not least, what to do to prevent cycles, redundancies, and inconsistencies. Because this is also a reason why a lot of people use Redux, don't they? Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. I and my colleagues do a lot of stuff in this area. We are visiting a lot of companies. We are doing workshops there, trainings, consulting, reviews. And by the way, we are also quite connected to the Angular community. I live in Austria, where we have Krapfen, you know, but I do a lot of stuff in Germany. Since 2008, I'm here every second week. I'm traveling across the federal countries. I really love it to learn about all the little tiny differences. Sometimes they are little tiny, and sometimes they are a bit bigger. And yeah, I really like to be here and to help companies with Angular in the enterprise. Sometimes we are also entering other countries. If we promise to behave well, they let us in. We are doing a lot of stuff meanwhile in the rest of Europe, and we are always happy to work together with people around the globe. Okay, so let's get started with the baseline architecture. For my baseline architecture, I'm using an NX monorepo. I'm using, this should not be a surprise, Angular, and I'm using the brand new NGRX Signal Store. Our architecture we very often start with is subdivided into business domains. A business domain is something from the real world. You know, the real world is where the pizza boy comes from, and we investigate this real world and try to mirror parts of it in our software. And such a part could be booking if we think about the flight booking system, or boarding. And quite often you have one or several shared parts. And then we start to fill those areas, those domains, which can be just folders or also different applications. It really depends on how you implement it. We fill them with modules. Modules that also can be folders, libraries, or perhaps also applications. And we are also categorizing those folders. For this, we are using the categorization proposed by the NX team. They tell us to go with feature modules. They are for smart components. They know about your use cases, and hence they are quite concrete. Obviously, we need concrete components. However, concrete components are not that reusable. This is part of the game. To get in some reusability, we have UI modules with dump components. They don't know about your use cases. They are super reusable by displaying this or that and raising an event when something happens. We have a module with data access code, services talking to the backend, and also data models in there representing your data. And we have utility modules with general purpose utility functions. Stuff like authentication, calculating dates, stuff like this. This baseline architecture, as we call it, has several advantages. One advantage is it brings a lot of order into play. There is less discussion about where to put something, where to find something. That's good. Another aspect is we can easily introduce access restrictions, like we are only allowed to navigate top-down, which is decreasing the possibility of cycles, of course, and also it is decreasing the coupling, because not everything can interact with everything else. We can just go top-down, which means feature can talk to UI, data utility, data can only talk to utility. The more important criteria here is just going from left to right. It's more important also in terms of domain-driven design and also in terms of having separated partial applications, subdomains or verticals, as you want to call it, that don't need to know much about each other. Because you want to change something here without breaking something there. Here in this case, booking can only interact with booking code and with shared. Boarding can only interact with boarding code and with shared, and booking and boarding are not allowed to interact with each other. Prevents coupling, prevents intermingling. We start with this quite often, but we also quite often adopt it. Sometimes we find out we need more layers or perhaps more dimensions, then the matrix becomes a cube, or sometimes we implement this with micro frontend, sometimes with NX, sometimes just with the Angular CLI, but the DNA is always the same. So for this here, I'm going with NX, and NX brings a lot of advantages. For instance, we can modularize our application with libraries. Each and every cell you have seen before on this matrix becomes a library in NX. And there can be access restrictions defining which library is allowed to access which further libraries. We use also NX for incremental CI/CD. That means only stuff that has been changed will be rebuilt. This speeds up the whole build process, obviously. We go with the build cache of NX, and we go with having builds in parallel in the cloud, which is a commercial add-on to NX. So the thing is, sometimes having that many libraries is not that fun, because in this case we end up with a huge amount of little tiny libraries. And so what we do in this case here, we don't use NX for the modularization, we use the sheriff, which is doing the same access restrictions via linting, but on a per folder basis. This gives you a more lightweight architecture. You just have folders, not that many different libraries. That means we use NX for everything else, and we combine NX with Sheriff to have this more lightweight folder-based structure. Let me show you a demonstration about this, and then we can discuss all the things lightweight stores on top of it. So what you see here is our NX workspace. It's a simple application that is about booking flights. And if we drill here in, we have the flights application. It consists of several domains. And if I drill in here, let's close this, we see a check-in domain, a luggage domain, and a ticketing domain. And there is the shared part. And one more time, if we drill in, we see our layers. We see the data layer and two feature layers. Those are ideas we borrowed from the NX team, and they work quite well. More or less what you see here in terms of the folder structure is our matrix. We have here the columns, check-in, luggage, share, ticketing. And here we have the rows, 2 items of the feature row and 1 items of the data row. If we look in here, we have ordinary Angular code. Meanwhile, it's fully standalone based. And there should be a nice flat search component somewhere. Also a standalone component that is importing stuff from other libraries and other modules of our system. And the best thing, and this is what Sheriff is doing, is if we try to import something we are not allowed to import. For instance, here I try to import something from the luggage domain. Even though I'm currently in the ticketing domain, I'm getting a hit on my fingers. And I really appreciate this, because this tells me, hey, Manfred, you are doing something wrong. You try to break the architecture. Please don't do it. So look here at this error message. It tells us, hey, you have ticketing feature. You are in the ticketing column within the feature row. And this means you are not allowed to access the domain luggage. You don't have any clearance. This is forbidden, or to say it a bit stricter, it's verboten. Yes, you know, if you use the German term, then people know you are really serious about this. You are meaning it as you say it. Okay, cool. So no broken windows. Also, if we call the linter here on the console, we get exactly the same error message. Also here, you don't have clearance. You see it here to access domain luggage. And that means we can integrate this in our build pipeline. And so the build pipeline will not allow to break the rules, to break the architecture. No broken windows. I really love this. Yeah, this is our baseline architecture. And now let's discuss what it means if we use this architecture together with a lightweight store. The first question that comes up here is, how granular should it be? How large, how small should it be? And funnily, such a lightweight store is mainly on a feature level, because a lightweight store is mainly a service. And you don't want to have a service responsible for the whole system. This would be one of those services that is far too large and that is coupled in everywhere. So mainly a lightweight store is really on a feature level, serving one or a tiny amount of components. And sometimes, if this feature level is too huge, you split it into sub-features. This is one big difference to the Redux-based world, where you have one huge store for everything. The second question is somehow connected to this. However, the answer to this question needs a bit more time. There is no easy answer for this. Where to put the store in terms of our architecture? Well, if we would stick with Redux, this answer would be quite simple, because in Redux we talk about feature slices. And as the name tells us, a feature slice is associated with a feature. And sometimes we pull it down on the data level, especially if we feel that several features of the same domain need to access the same data. So in the case of Redux, it's simple. If we switch over to lightweight stores, it's not that simple anymore. So a lightweight store, for instance, could live on a feature component level. Just imagine a very complex feature component that has a lot of state. In this case, this feature component could have its own local store. That means we are using the Signal Store like the component store before. We could also put it here on the feature itself. Perhaps several components make up this feature, and so we need some access from all the components to this one very store. We could also pull it down to the data level, as seen before, because perhaps several features need to access the same data structures. In this case, the data layer will expose the store. And sometimes, not every time, but sometimes we might have a store on the utility level, especially if you have stateful utilities. The thing is, most utilities are not stateful. Think about calculating dates. This is not stateful. Or displaying some status message. This is also not stateful. However, if you think about authentication, of course, this is stateful. They have a state, namely the authenticated user and all their properties, roles and other properties. So you need to manage it, and hence you can decide to put those properties into a store. So in this case, we have a store on the utility level. But there is another location, and this might come as a surprise. We can also have a store on the UI level, on the level of dump components. And this might really come as a surprise, because usually we say, well, we don't want our dump components to access the store. This is, I think, the most known rule in the area of stores. Don't use the store within dump components. However, what people really mean with this rule is, don't use the global store from within a dump component. Because the dump component should be reusable, and we don't want to trigger the dump component several backend calls. However, sometimes dump components are really complex. That means they need a lot of data. And so we can decide to give those components a store of their own. In this case, the store becomes an implementation detail. The caller is not interested into whether the data is managed by a store or somewhere else, but for us it's helpful to have a store in there. Think about a scheduler component with a daily view, a weekly view, a monthly view, a yearly view, a lot of different data, dates and repeating dates and so on. In this case, a store might come in handy as an implementation detail. We don't expose it. To wrap this up, at the end of the day, a lightweight store can live everywhere. It can be on a component level or on a module level. And if it is on a module level, we can expose it for other modules. Think on the data layer. There we are exposing something. Or it can be hidden inside the module. Think about the feature level. So we are quite flexible in here. Let me show you all of this in an example. In my example, my flight search component, responsible for searching flights, is getting a store. And as you see, the store is just a service that is injected, and I'm getting out here several signals that are data bound. A from signal, a to signal. This is my search filter. I want to fly from here to there. I have my entities, the found flights, and then I'm triggering some methods to load something or to update the filter, the search criteria, and so on. So what you see here in practice is this unidirectional data flow. Commands go up, and data flows down via signals that are data bound. In my case, the store itself is located on a feature level. We have it directly here. Look here. We have feature booking with some components, and here we have the booking store. So it's really located on the feature level, as local as possible and as global as needed. And funnily, if we look into it, I don't go into details here, but here we see a very funny aspect of the NGRX Signal Store, because what we have here is a higher level feature. It's a feature that is connecting the store to a data service. Here it's a flight service. Usually, you start with, in your first examples, with defining some state, like a flights array, or some computed signals, or some methods for loading flights. However, you can group some of them in a generic function like with data service, and now this function gives you everything you need on a regular basis to get a store for this or that use case. Here you get a store for loading entities. You just connect a service and a flight filter, and you get all those signals and all those methods. Nice aspect of the Signal Store. Okay, so what we see here is it's co-located with the feature, and it's on the level, on the granularity of a single feature. So the next question we might encounter is what to do with global versus local state. And the thing is, of course, if our stores are little, if they are on a per feature level, we might have several of them. And sometimes we might have several on different layers. We might have one for our feature and a more general one on the domain level or on the utility level. Think about the user store that knows about the authenticated user. It's very likely on the domain or utility level. So how bring all the data together? Well, one possibility is to hide everything behind a service that serves your feature, a feature-located service. Or, have you seen this animation? It's really cool. Oh. I'm really proud. I could do this the whole day. Or you connect your stores with each other. Here we need to take care a bit because we don't want to have a change cascade. We don't want to have one store triggering another store, triggering the next store, triggering the first store. But if we just read, don't write, if we just read from a lower level store, we should be safe. And this means we can also use the data from down there in a reactive way within Computed. So let me show you an example for this. What I have here is a ticket store, or perhaps we should start with the user store, outstore. The authentication store, no, this isn't it. The authentication store is in the shared area of my application, util out, and here we have the outstore. And as you see, it's a very simple store, it's a demo application. I'm just assuming that the user with this ID is logged in. I call this authentication for very honest users. And besides this, I have here a feature that is called Next Flights. It shows the user's next flights. And of course, there we have another store. I call it Ticket Store. It displays the user's next tickets. And you see, for loading the tickets for the given passenger, I need to have the current user ID. And that's why I'm injecting the authentication store. As long as I'm just reading from this authentication store, and as long as I'm just accessing lower level stores, it should be totally fine. And this is what happens here. I'm taking out the user ID, and then I'm doing my thing. Okay, so one last thing, cycles, redundancies, and inconsistencies. So let's think it through, how to prevent all of this. I have a good message. We have layering. That means it's not that easy to produce cycles. It's still possible, but not that easy. We can just communicate into one direction. However, when it comes to redundancies, then I think it's not true that Redux prevents redundancies, because no one prevents us from writing the same stuff into this feature slice and into that feature slice. However, Redux has a wonderful thing that allows us to find out quickly that something is going on there, the Redux DevTools. And we can also connect non-Redux-based stores to the Redux-based DevTools to look into them to find out what's going on there. And this is my last example of today. It's a very quick example. So if you look to my stores, I have this helper function. It was written by my colleague Rainer Hanekamp, and it's open source. It's called with DevTools, and this connects our Signal Store to the known Redux DevTools. And here in my application, when I'm searching for flights and looking into my next tickets, then I get some data into my store, And here we have the DevTools to find out what's going on here. Here I see what's going on in the booking feature, in the authentication feature, in the ticketing feature. When it comes to booking, I have those flights that go from London to Paris. Okay, cool. So if you like all those thoughts about architecture and how to do it in a way that allows the application to evolve, you will very likely also like our free ebook. Feel free to download it here. Meanwhile, it is in its 6th edition and we have 20 chapters. And there are several chapters about using signals in a good way for your architecture. Also chapters about the Signal Store and custom features. Okay, so let me come to a conclusion. What did we see today? We have seen that lightweight stores have the size of a subfeature, feature or subfeature. We have seen they can live everywhere throughout our different layers. We have seen they can be orchestrated by a feature service, and they leverage layering to prevent cycles. Also, they should use the DevTools so that we find out what's going on in there. And in general, our baseline architecture is vertically sliced by domains, domains that don't know much about each other. We have horizontal separations by layers, and we enforce access paths with Sheriff and/or Annex. Furthermore, we improve build times with Annex. And there is one last thing I really want you to remember. Besides all of this is important, but one last thing I want you to remember, namely, please never ever put mustard into your Krapfen. It's not fun, and don't play with food. That's it. So here you have my contact data. Follow me on Twitter or on LinkedIn to stay in contact. And I have already uploaded my examples and slides to my blog. You'll find it here. So thanks for having me.